So this is not how I would have done the rehabilitation on the hill here. Well, hello there all you absolutely magnificent people, and welcome back to another episode of An Ecologist Plays. We talk about nature while playing games. My name is Will, I'm an ecologist by training, and we are back in Coral Island here. And today we have the tree planting festival, which we will get to, well, I guess right about now. So let's chat about restoration of forested ecosystems. So a nice little team building exercise here, with the community working together to do this. Of course, it's very important for communities to work together to achieve these types of goals, because restoration, well, is a difficult thing to pull off. Sure, there are people on Earth that have done restoration kind of all on their own, but the majority of successful rehabilitation efforts have been the collaborative efforts by communities overall. So as you can see here, illegal logging has caused the Pervo woods to actually become a barren wasteland, and it's up to us to reforest the forest here. Of course, we can see some small animals like little rabbits over here in the area still, but generally very few animals would be present in these highly deforested environments. Now we can buy pine cones here, and maple seeds and oak seeds and wild seeds. We can actually buy a lot of seeds here, and normally I would be very tempted to actually buy a bunch of these seeds. However, there is one thing we need to consider, and that is that we do not know where these seeds actually came from. We do not know the origin. If they were locally sourced, sure, we would be planting them. But these could have been collected on other islands or in other ecosystems. Sure, it may be the same species as the ones we have on our farm, but they could be different populations. And if we were to introduce pine seeds or maple seeds or the oak seeds here into our farm, we are bringing in genetics from other areas. And although that could be good, gene flow and stuff like that, it could also mean that we are doing what we call genetic swamping, which is when you are bringing in the genetics of populations that are not adapted to conditions there we are planting them. And the genetics you are bringing in could therefore muddy up the genetics of the local population, meaning that they are less well adapted for the environment there we are planting them. And it's something we don't really consider. We'll chat about that in a moment again, but it's something we generally do not consider. So first of all, what we are going to do is we are going to clear the area. Now, I've got a problem with the fact that we've got to chop out these trees here. So yes, of course, I completely understand removing the rubbish here, but I've got a problem with actually clearing the little plants here and clearing the stumps and the logs, because those actually are extremely important. The plants, for example, will prevent water from just running off the soil surface here. And on this barren wasteland we've got here, the impact of raindrops on the soil will actually result in two things potentially happening. First of all, it can result in finer soil particles splashing around and clogging up the pores of the soil there. And that will lead to the second thing happening, which is instead of infiltration of water into the soil, it runs off the surface, especially on this slope over here. So removing the plants here is actually the wrong way to go about doing things. I wish I could leave the plants here. Likewise, leaving the logs here would actually be very, very useful, because slowly but surely they are going to decompose and result in more nutrients in the soil, meaning that the plants you plant here will do better. Now, removing the logs here just means you're exporting potential nutrients rather than letting it decompose into the soil here. You are taking it away, doing goodness knows what with it. So I've got a problem with that. But what about the logs? Surely we can take away the logs. Well, the thing is that these logs, they're not going to regrow, but they've got lots and lots of roots in the soil here. And when those roots decompose, again, it results in nutrients right there in the soil. So removing these logs also is kind of a bad thing to do. I like to, for example, when I take out annuals in the garden, I like to just chop it off at ground level, let the roots decompose, instead of pulling out the roots and disturbing the soil microbiota in the process, the microorganisms in the soil. I like to leave it there where it is. So just chop it off, let the roots decompose in place. However, we do need to do this for this tree planting to be successful in the game here. We need to chop out the logs and the stumps that are present, unfortunately. Now, the logs would actually have done a second thing apart from decomposing. They also would catch any seeds being blown around in the wind or washing downhill with the water that is running off. And they would have fulfilled a very important role in the process there. Unfortunately, however, we have to take it out. So, this is not how I would have done the rehabilitation on the hill here. Having said that, maybe these plants that we are taking out are actually weeds, are actually exotic species that would be competing with the plants we are trying to establish. So there is that potential thing that, okay, maybe we should be taking them out because they are going to be doing that. We don't want exotic pioneer species to establish in this area that we are trying to reforest, because first of all, pioneers do very, very well. So they would have the competitive advantage in terms of establishing in this environment. Pioneers tend to be fast-growing species. They love disturbed environments, which this most certainly is. They also have very, very high reproductive rates, so they would be producing a lot of seed and potentially would really outcompete the plants we are trying to establish here. Now, of course, when we are reforesting this area here, and we'll get back to that in a moment, we will try to establish a mixture of pioneer plants and more climax plants, plants that generally would come into this area later on in succession. But we would try to have pioneers that are locally found in this area, so they're not exotic pioneer species. So let's say we are taking out these little plants here because they are exotic pioneer species, and we want to give our plants that we're trying to re-establish here the best fighting chance possible. Now, just looking out over this landscape, I mean, yeah, this is a massive area that we are technically trying to rehabilitate. Okay, and now that we have actually removed the rubbish from this area, now of course it is time to try and prepare the soil. What we're doing here is we are tilling the soil. I'm not a big fan of that. So the reason being that the soil as it is, yeah, maybe it is compacted, okay, but tilling the soil does stuff. It disturbs the earthworms that are present in there. It disturbs the fungi that have their little fungal threads through the soil here. It really just turns up the soil and it brings to the top, close to the surface, some of your subsoil that may not have a lot of nutrients, and it takes your nutrient-rich topsoil and actually takes it deeper into the soil. So it really turns over the soil and makes it potentially a bit of a problem. Okay, it mixes the soil, and you may think, okay, that's a good thing, but it could actually take the most nutrient-rich soils deeper into the soil, where seeds will not be growing or trying to establish, and where the initial roots of the plants you're planting here will not be. So what would I do if it were up to me? Instead of tilling the soil like that, I would actually be bringing in mulch. So you have got logs and you've got plant debris. I would bring in a mulcher or a wood chipper and chip it into fine wood chips, and I would put that all over the surface here, and that would do multiple things. First of all, especially on a slope like this area over here, if you have mulch on there, it would prevent erosion of the soil here, so it will intercept raindrops splashing onto the soil, so it doesn't cause compaction or further compaction, and it doesn't result in runoff, serious runoff at least. So mulching the soil would be very, very important. Of course, the mulch there also over time will decompose and result in more nutrients in the soil there. It results in better infiltration, less runoff, better nutrient status of the soil. So I would mulch this entire area. And then in there, if it is severely compacted, there where you want to plant the plants, I would then maybe dig around in the soil a bit and also put in compost or some organic matter to try and give the plants the best fighting chance. Now, we are planting festival trees. Who knows what these festival trees are? Hopefully they are local species that are found in this area. And as I said, you want to bring in some pioneer species, and you also want to bring in some climax species. The pioneer species would be fast growing. They would cover this area in a canopy relatively quickly, hopefully within 4 or 5 years. Of course, during that time period, this soil is still vulnerable to desiccation and vulnerable to runoff and erosion, those types of things, meaning that it is again very important to mulch this area, brush back this area, have anything present on the soil here, leave vegetation that is there, that is indigenous, anything to protect the soil. Okay, we tend to think that the plants are important because their roots bind the soil here, but that's really not that big a deal. It's not the main reason we want plants here. The main reason we want plants here is so that when it rains, their leaves and their branches will intercept the raindrops, take some of that kinetic energy associated with the raindrops splashing onto the soil, absorb some of that, and then let the water drip down onto the soil more gently, resulting in better infiltration, less soil compaction, less runoff. So we want some pioneer species to try and cover this area as quickly as possible. But pioneer species tend to be short-lived. In trees, they would be 10, 12 years and then they die. So you need to plant some plants that will take longer to grow, but by the time that they are larger and ready to take the role as the dominant canopy species, the pioneers are dying away, leaving a gap for them to establish. Now, unfortunately, it does seem that we are planting one species throughout here. We don't see any variation in the trees here. It seems we are basically planting a monoculture. Again, not how I would go about doing this. Sure, this is better than not doing anything, but you know, it's not the best. I would mulch this area, I would plant a variety of species. Variety is the spice of life, and as I was discussing with my fourth years this morning actually, you need a great diversity in the ecosystem. And you need some common species and some rare species as well. So species that aren't generally very common in the landscape, because the more species rich an area is, the more resilient it is. And so yeah, we don't just want to plant one species here, because if something were to happen, let's say for example there's a disease that affects only this species and it comes into this area, it could wipe out all the trees we have planted. So not great. Think for example American chestnuts being very susceptible to that fungal infection, chestnut blight. Okay, that's a bad thing that has affected the American chestnuts and wiped out most of the population. If we just have one species in here, this rehabilitation effort here could suffer the same fate, where every tree here could be susceptible to that blight or that infection. So we want many species here so that even if one species were to be affected by a fungal infection or bacterial infection or disease or whatever, climate change as well, other species can still survive and you don't lose this forest a second time. Nonetheless, here we are. We have done our things. We have planted a whole bunch of trees and hopefully they grow and do well. Of course, it is a nice community event. I have been part of tree plantings like this in the past. Usually, you know, we do try to have multiple species together instead of just one species or maybe even two species together. Now, there is something to be said about the spacing of the trees here as well. So yes, we've got the trees that we planted over there and they are quite far apart, all right? But we also have some shrubs and some flowering plants over here. That's great. Okay, it makes me feel a little bit better about the fact that we have actually planted just a bunch of a single species of tree. At least we do have a meadow forming over there as well. And they seem to have sowed some grass seeds as well that miraculously have germinated immediately. Now, normally this is how we plant it. Okay, we plant these trees quite far apart, and the idea being that you give them enough space for the roots to grow and take up nutrients without competing with other trees. And you know, that does make sense. However, if you're trying to establish a forest ecosystem, there is a different strategy you could use, known as a Miyawaki forest, named after Dr. Akira Miyawaki, which was a Japanese botanist. And he developed the idea of planting trees, native species, tightly packed together, whole bunch of different species in one area, but really placing them very close to one another. And the idea then being that competition between individuals actually resulting in each one trying to outgrow the competitors next to them, resulting in very fast growth or very fast establishment of natural forest ecosystems. Potentially in as little as 20 to 30 years, you could have a native forest establishing instead of hundreds of years. Now, of course, the problem with doing that is that you need many, many more trees. For this area over here, we would need a few hundred trees, because where one tree is planted, you would actually have like 10 or 20 of them planted. And you think, okay, well, surely you're going to lose a lot of species, a lot of plants that you planted, but it turns out they actually have surprisingly high survival rate, with almost half of the trees potentially surviving. So that's actually quite good. But you do need a high input of trees. Okay, so where we could have 50 trees here, we may have needed 1,000 trees or more of multiple species. The idea being that different species fulfill different roles. So some will form the canopy eventually, some will be in the subdominant layer, or some will be more shrubby species lower down in the forest, instead of a monoculture of one species forming a single layer like a commercial plantation. You have got a bunch of species together, each competing with everybody else, but at the same time also not being outcompeted by the other ones around them. So the Miyawaki method is something that I would really like to try out sometime, and maybe when I rearrange the food forest in our garden, I will actually try that one, where the trees are planted much more tightly together, really simulating what a forest ecosystem looks like. Because this is a human idea of a forest ecosystem, not a natural forest ecosystem. Nonetheless, it is better than not doing anything. Okay. Now, of course, illegal logging, illegal deforestation is generally a major catastrophe and does result in large areas of the world losing their forests. Now, before I forget, I do have in my pockets this year, I've got a morel. And for some reason, I've been pronouncing this moral my entire life. Turns out it's pronounced morel or morels rather than moral. I don't know. We don't really have them in South Africa, so I've never really been introduced to them in person, and so I've just been mispronouncing them my entire life. Anyway, we've got the morel over here, and that, I believe, is the last thing we need to donate for springtime. And then the spring cessation is done. Oh, and we unlocked sugarcane seeds. Well, that is lovely. And ooh, something's happening here. The hot spring. Okay, the hot spring is now open. Wonderful. And it is also raining, and that means it is time to go to the ocean again. I do want to go to the blacksmith first before we head into the ocean. However, they only open at 9 o'clock, so we may as well do a little bit of fishing in the meantime and see if we can catch anything interesting in the river over here. Oh, this one is putting up quite a fight here. But patience is the name of the game here. Ooh, almost lost it. And we got a barramundi. But oh, the barramundi here is a fascinating species. Okay, so it says there that its habitat includes streams, lakes, and coastal waters. And notice that it includes fresh water and salt water. And sometimes they occur purely in marine environments, but generally they occur in rivers and lakes, so in streams and fresh water. And then when it's breeding season, they actually move down to estuaries and in the tidal flats. That's where they will be spawning. And females can lay millions of eggs in one spawning season. So lots and lots of babies potentially being produced by them. And the thing is that they don't care about the babies whatsoever. So first of all, there's no parental care. They just spawn and leave them. And they also are known to eat the babies occasionally. So food is food, I guess. So they will eat crustaceans and smaller fish as well, including other individuals of their own species. And they also generally will start out as males. And then after at least one spawning season, they change into females. So they are what we call sequentially hermaphroditic, meaning that they start out as one sex and switch over to a different sex as they get older and larger. And that is quite fascinating. Now, the thing is that if they were to be the other way around, first female and then males later, the thing is that would happen then is they wouldn't be able to produce as many eggs as a female than they would if they started out as a male and then changed over to females later. So it's a fascinating species, really designed to make use of their environment perfectly by having a very, very high, what we call fecundity. Okay, the breeding potential of the species is very, very high. Really cool, quite a good eating species apparently as well, known by a variety of names, but barramundi being the most common name they are known as. And interestingly enough, barramundi is an Australian Aboriginal term from the Rockhampton area in Queensland, I believe it is, meaning large-scale river fish. And originally it was a name used for different fish species, actually for the bony tongues or the Australian arowanas, they're also known as. Those are river fish with big scales. So that would have been the original barramundi, but barramundi was then later kind of hijacked for this species to kind of appeal to the market. Okay, and it resulted in people going, "Oh, I want that fish. Okay, I'm going to eat that fish." So barramundi became a very popular eating fish. Now, the reason we are here at the blacksmith, though, from one topic to another, is I do want to upgrade my tool. I want to take my normal old hoe here and change it into a bronze hoe. And we've got everything we need right over there. So we're just going to upgrade that, and we should be able to collect it tomorrow. All right, and now let's go diving. Now, we have got a very interesting bivalve over here, the Jackknife Clam. Now, the description here with the Jackknife Clam says that the shell's rim is rather sharp, rather like a razor. And that is partly where they get the name from. Jackknife clam also, I mean, jackknife is like a little pocket knife, okay, so it resembles that in appearance. And they're also known as razor clams, partly because the top part is so sharp, and if you step on it barefoot, if you're going to the beach and you happen to step on a jackknife clam here, yeah, your foot can be cut open in the process. So not great, you know. So you need to look where you are stepping, and thankfully you can kind of spot where they are buried in the mud, because they've got a little keyhole opening, relatively easy to spot if you know what you're looking for. But they're also known as razor clams because they resemble those typical straight razors. Okay, so that's where they also get their name from. Now, in many areas they are considered a delicacy, so they are collected. But the thing is, they are very, very good at digging, so they can actually dig into the soil faster than you can dig them out. So it's a little bit difficult to actually get a hold of them. And so one thing that professional clammers will do, once they find the keyhole opening, they pour a little bit of salt on that clam, and that causes them to actually come to the surface, and they can then very easily kind of just gently pick them up, okay, rather than having to dig after them. Now, if you were to catch one out in the open, for some odd reason, if it were to be out of the soil and in the water, they can actually swim surprisingly well. They put their shells together, and in the process they are able to swim surprisingly well. Now, just another random little fact, as we have this little coral site actually being cleared, in Scotland the jackknife clams and the razor clams, they're known as spoots because of the spouts they create and comes out of their shell when they're digging into the mud. So they need softish mud to dig in quite easily, okay, so they wouldn't be found in areas where it's more difficult to dig into. So soft mud, great place for them. And then when they're digging into the mud, they then have that jet of water exiting their shells. So spoots. That's such a fun name for a little razor clam. Now we have two very, very distantly related species here in the same area. We've got the urchins here. And you may be wondering, okay, well, what other animal in this general area are related to the urchins? Because there aren't any other spiny things in this picture here, but starfish are related to urchins as well. Both of these, the starfish as well as the urchins over here, belong to the echinodermata, basically meaning the spiny skins or the tough skins. Dermata referring to skin, echino referring to spikes or spines, something along those lines. Typical, urchin basically. And in both cases here, with the urchins here as well as the starfish, they have those tube feet that you can see in the little photo over there of the underside of a starfish. And they will use that along with a hydraulic system in their bodies to move along the seafloor. Now, previously I mentioned urchin barrens, where you could have kelp forests being decimated by urchins, and that is because, well, urchins will graze on the algal sporelings or on the sporelings of the kelp. So the little babies that are trying to establish, germinating, or the spores germinating, establishing as little sporelings. Well, if there are lots of urchins in the area, there's a good chance that those little sporelings of the kelp will be grazed down by the urchins. And then the kelp may not have the opportunity to actually establish in the area. And why would there be so many urchins in an area that kelp can't establish? Well, because we as humans are stuffing up the environment, as we tend to do. Some cases, in some areas, the main predators of those urchins have been removed. Think, for example, of the removal of sea otters off the coast of California. And sea otters, well, they love eating urchins. And if we remove the sea otters, then there's very little eating those urchins, and the population just boomed. And as a result, well, the urchins ate a lot of the kelp that used to be in those areas. And so certain areas of the kelp forest just got decimated to such an extent that they became those urchin barrens, where there were lots and lots of sea urchins, and every time a few little sporelings tried to establish of the kelp, they would be grazed down by the urchins. They stood no chance whatsoever. Whenever we tend to remove, as humans, predators from an ecosystem, it will have impacts on the lower trophic levels, those species that are lower down in the food web. But anyway, we have cleared another coral site. So now we're really making headway. There's one left over here, another one over there, and then I guess we're moving into deeper water. And as we do so, we are going to encounter new species. Of course, we've got the little sea mushrooms here that we also saw previously. Some more kelp as well. We're not going to harvest either one of those two there. We're actually just going to call the anchor and head home. And you know what? I think that's a good spot to end today's episode. So thank you very much, everyone, for joining me on our little adventure here. Hope you had fun. I enjoyed talking about rehabilitation. I recently did a very detailed video in Enshrouded as well about rehabilitating arid rangelands. So have a look at that one on the channel as well if you would like to learn more about rehabilitation. But for now, this is where I'm going to call it today. So thank you very much, everyone. I hope you have a wonderful day further. And until next time, stay safe. I'll see you all soon. Cheers, everyone.